Guys, welcome back to my YouTube channel. Have you ever wondered how to turn messy, chaotic data into crystal clear insights? Then this video is for you. In this video, we are diving into data cleaning marathon, where I will take 4 real-life messy data sets and transform them using nothing but Python and some serious data cleaning skills. Yes, from null values to inconsistent data type to having HTML tags and URL in our rows and rogue outliers. I will be handling it all step by step. So whether you're a beginner or you're just brushing up your data cleaning skills, this video is for you. I'll be teaching you real world techniques that every data scientist and data analyst must know. But before we hop in, wait. Don't forget to subscribe, like, and share. So this is the first data set we are going to be cleaning. So we have already created a Python file for it in our Jupyter notebook, and we have named it the Loan Data Cleaning Tutorial, right? Now, these are the data sets we are going to be working on. Like we see, we have 5 different data sets we are going to be cleaning. Now, this is the first data set we are going to be working on, which is called the archive 28. Now, as you can see, we have already extracted this archive 38, so we can actually access it. Now, when you look at this, you can see tests and we can see train, right? Now, what is this telling you? This has to do, I think this has to do with machine learning projects, where they have the test train data, the test and the train data. Like we know, train data set always has more data compared to the test data set, right? Which we actually just work with maybe 20% or 30% of the data, right? So we are not going to be making use of this particular data set. We are going to be making use of this. The first thing we have to do here is importing our necessary library. Now let's say importing libraries. Importing libraries. Now, when you look here, this is where you run your code, right? This is where you run your code, start writing your code. Now, this is where you can change to code or markdown. So markdown is basically your text, while code is normally for writing your codes, right? Now, when you use this hash, right, in a code, right? Maybe let's say we are in the code section and we are using this hash in a code. This hash simply means comment out, right? It simply means that whatever you write after this hash will not affect or be added to your code when running your code. But in a situation when you're making use of this as a markdown, right, this hash actually stands for how bold you actually want your text to be. Now, one hash means you want the text to be bigger. While double hash, as you can see, the more we add hash, the smaller the text become, right? Now, let's go ahead and run this. Now, when you run this, you see that we have successfully written a text that says importing our libraries, right? Now, remember I told you about the commenting out using hash, right? Now, we want to import pandas, right? We want to import pandas. Now, this comment out ensures that anything you write, right, after this hash does not affect your code when you are in the code section, right? Now, when we say import pandas, then we say import pandas as PD, right? Now, you see that this successfully goes ahead to import or execute pandas, right? You see that this automatically goes ahead to actually import pandas, right? As you can see, this doesn't actually affect your code. Now let's try eliminating this hash and see what happens. When you eliminate this hash and run this now, you see that it is showing as a code, right? Let me say I say importing instead of import, right? And let me run this. As you can see, it says invalid syntax, right? But let me go ahead and add this hash and then run it again. As you can see, it works. This is the use of hash when working in Python. But let's go ahead and delete this because this is not what we want to do now. I don't really know why I'm so dehydrated today. Sorry, please, let's get back. Now, what we have to do is, since we have already created a heading that says importing libraries, right? What we have to do is import the necessary libraries we want to use. For a start, we have to import pandas as PD, import pandas. as PD. Then we also import numpy as NP. So we are not doing any visualizations, right? We are not doing any visualizations. This is just thorough data cleaning tutorial. But we can still go ahead and import visualization packages, like let's say importing Seaborn as SNS, Seaborn as SNS, right? Then we can also decide to import matplotlib, but that's not necessary. But the most important thing I want us to import is import warnings. So this actually helps us eliminate or ignore all warnings we get when writing our code. Now we can simply say warnings dot filter warnings, right? Filter warnings, and let's use ignore. Now let's go ahead and run this. Okay, this should be Seaborn, please. Now, as you can see, we have successfully run this code, right, with no error. Now, the next thing we have to do, of course, is import our data sets, importing data sets. And let's go ahead and turn this to a markdown and run it. Now, to import data sets, we actually have to declare a variable. Now, of course, we all know if you actually use Python, the variables we always use is VF, right? So this is just a variable. It can actually be whatever you want it to be. You can simply say TechUp, right? TechUp, right? That's the name of the variable. So we can simply say TechUp is equals to pd.read, right? Then we say underscore CSV because that's a CSV file. Then we can go ahead and we said we are going to use the train data set. So we can go ahead and copy the 5 parts. So we copy as parts, right? Then we can come here and do this and paste it here. Then at the back we say read. Now let's go ahead and run this, right? As you can see, whatever variable you call it, it doesn't really matter, right? It doesn't really matter. You can call it df, you can call it TechUp, you can call it whatever you want to call it. So the variable doesn't really count, right? Now the next thing we have to do is let's go ahead and do our data investigation. Data investigation. Now let's run this. Now to do our data investigation, so we have when we talk about data investigation, you just have to we are trying to get more information on our data. That means exploit our data sets and know what is actually happening in the data. Now the first thing we have to do is let's look at the first 5 rows and we say TechUp.head, right? Now when we run this, as you can see, this is actually our data sets. As you can see, we have different columns. We have the loan ID, we have the gender, married, dependents, education, we have self-employed, applicant income, co-applicant income, loan amount term, then credit history, property area, and loan status, right? Now, one thing you need to notice when you're looking at this is the first thing you notice is the inconsistency in the column names, right? As you can see here, we are having self underscore employed, while here we are having applicant income applicant income, sorry, and here we are having loan underscore amount underscore term, and here we are having credits underscore history. Now, as you can see, there is inconsistent data column name, right? We have an inconsistent column name. So we also have to put that in mind because we are going to be changing that, right? But let's go ahead with our data investigation. Now, the next thing we have to do is let's look at the first last rows. Sorry, rows. And let's do then we do sorry, what am I doing? We do TechUp.tail. Now let's run this. Now, as you can see, this gives us the first last rows, right, of our columns. Now, look at this. We can already dictate an error here. When you look at this, we are seeing 3 plus, right, which we are having a non-numerical character attached to this, right? Now, We are not handling that yet. We are leaving that, right? Now, the next thing we have to do, let's look at our statistical information. Now, to do that, we say describe. Now, this gives us the statistical history of our data sets. Now, let's run this. Now, when you look at this properly, you can see that this is the count of each column, right? This is the count of each column, right? Now, when you look at this properly, okay, before we go ahead, let's go ahead and just say df.info. There's something I would like to explain there. df.info. Now, when you look at this df.info, you can see that we have a total of 64 entries, right? Which simply means that we have a total of 64 rows, right? A total of 64 rows, and we have a total of 13 columns, right? Now, remember that now this is giving us 0 to 613. Remember that in Python, we start counting from 0, not 1. In Python, we start counting from 0, not 1, where we have our 0, 1, 2, 3, not our 1, 2, 3, right? Now, when you look at this, it simply means that we should have a total of 614 entries for each columns, correct? But now let's go to our describe, right? When you go to our describe, this is giving you the count of each columns, right? Now, when you go to applicant income, you see that it's giving you 614, 614, 592, 600, 564. Now, from this, you can simply deduce, or we can simply get to say that we have missing values in some columns, right? As you can see, the only complete columns we have in our numerical columns is our co-applicant income and our applicant income. While in our loan amount term and credit history, we are having missing values. Now, when you do 614 minus 592, 614 minus 600, 614 minus 564, it is going to give you the total amount of missing values we have in our columns. Now let's move ahead. Now, one thing you also need to know about describe is it only works with numerical columns. Now, I mentioned that describe is used to get statistical information on our data. Of course, we all know what statistics is, where we are talking about our mean, media, and everything. So the describe only works with numerical columns. Now, when you look at this, you will see that there is no categorical column here. Is because describe works with only numerical columns. Now, when you look at this, you can simply deduce also that we have some missing values in some of the columns, right? Now, when you look at this, you know we have only 1, 2, 3, 4, 5, 6 columns that are complete out of 13, right? Now, another thing you need to look at is the type. This simply means data type, right? Now, this is simply telling us the data type for each of our columns. As you can see, loan ID is object. Object means categorical columns, which is just like our text, our string, right? While integer, applicant's income is integer, while the rest are floats. Integer is just our numbers like 1, 2, 3, 4, 5. Float is our numbers with a decimal point, right? Like this now, this is a float, okay? Now, this is what this area is telling us about, right? But now, when you look at this, even though we are not going into that properly now, but when you look at this properly, well, there's one thing you will notice that most of the data types are incorrect. Now, how do we know? Now, let's look at, for example, let's look at dependents, right? Now, when you go up, you see that dependent is giving us numerical. But when you come here, you see that dependent is giving us an object. That means it's telling us that is a categorical data, which is incorrect. This simply means we have to go ahead and change dependent from categorical to numerical. But we are not going into that yet. Let's move ahead. Now, the next thing we have to do is let's check for missing values. Now we say checkup dot is no dot sum. Now let's run this. Now, when you run this shows us that we have different missing values. We have missing values in the different columns. Now there's a library I like importing, which I forgot to import, and I call it the missing null. So I can say from imports missing null as MSNO. Now let's go ahead and run that. Now, what does missing null do? Missing null actually helps us to visualize our missing values. Now, let's go ahead and visualize our missing value, right? To do that, what we have to do is, let's say MSNO dot bar, right? Now, what is the name of our data frame? Checkup, right? Checkup. Now, let's go ahead and run this. Okay, let's wait for it to come up. It's loading. Now, as you can see, this has simply visualized our missing values, right? Now, look, this actually consists of each columns that we have in our data frame. Now, like we mentioned that each column should have 614 rows. Now, any column that doesn't have 614 rows, we can simply say that it has missing values. As you can see, this we have missing values here, we have missing values here, we have missing values here, we have missing values here. So this is what missing null does. It actually helps us to visualize our missing values. Okay. Now we have successfully done our data investigation, which actually helped us to draw more information on our data and understand the various problems we have in our data. Now we have to go ahead to our data cleaning. Now let's say markdown and run. Now, the first thing we have to work on is handling inconsistent column names, right? Now, to do that, let's go ahead and say checking columns. And let's go ahead and say checkup.columns. Let's run this. We have to go ahead and rename these columns, right? Now, to do that, we just create a new cell, of course, and we simply go ahead and say checkup.rename, right? So we specify the columns. So this is columns equals to, now let's say applicants. To avoid errors, let's just go ahead and copy this. So let's say applicant info, be applicant income, please. So let's say applicant income, all right? Then new would be applicant income, then underscore, right? Then the next one would be co-applicant income. So co-applicant income, then we say, say new co-applicants, control V, co-applicants income, co-applicants, this should be co-applicant underscore income, right? Then the next one should be loan amounts. Then we'll say loan amount. Okay, loan amount, then new loan amount. Then volumes equals to have to put our dictionary here. And let's run this to see. Okay, now if you see, we actually made a mistake here. Say on the score. Now let's run this again. Loan applicant income or applicant income loan. Yeah. So as you can see, we have actually successfully changed our data type, correct? Now the next thing we have to do is we have to go ahead and handle missing values. handling missing values, right? Now, in this marathon, we are going to be handling missing values using various methods, But for this particular project, we are going to be handling missing values using a backfill and a forward fill method, right? Now, before we go ahead, let's create column here and let's say checkup underscore checkup dot is null dot sum. Let's run this. Now, this is showing us the various columns that actually have missing values. This is to enable us know the columns we are actually handling missing values for, right? Now, to start with, let's go ahead and say have to handle for gender. So let's say tech up. Now, this should be .bfill, right? Now, we also go ahead to, let's just copy this, right? And let's just paste this here, right? Then we can simply go ahead and change this to married. Let's say married. Now that should be the second one. So we say married here, okay? Then we also say married here, right? Then we can also go ahead and copy this and take it to the next line. And we copy out dependents. And we say dependents. Then we can also go ahead and copy this and paste it here. And let's say we have missing values for self-employed too. Self-employed. Now we say self-employed. Then we also say self-employed. Then let's just simply use FU here, forward fill method. Then we can simply copy this and let's paste it. And the next one we have is for loan amount. So this is loan amount. So we paste this here. Then we also paste it here. You can simply go ahead again and copy this, right? Then we can go ahead and paste this here. Now there's something I'm noticing. I thought we actually changed all those columns. So why are they not reflected after we changed them, right? You can see here that we changed all these columns. They were reflecting here. So why are they not reflecting, right, after changing them? Now let's go ahead and do something. Let's copy this. Now let's go ahead and delete this. Now let's run this, right? Now let's paste this. So I see takeoff dot rename applicant, okay, loan amount. So let's run this. Now let's see check results. Let's say checking results. We say let's say checkup dot columns. Let's run this. Now this is not reflecting. It simply means we are doing something wrong, so we have to go back and handle that. So even if it is showing us it's reflected here, but it is actually not reflecting. Now let's go ahead and please handle that, right? So now let's go ahead and check what we are doing wrong. Why is this code looking perfect to me? But I feel like there's one thing we are missing, and that is our in place, say as this equals to 1, as this equals to 1, in place equals to true. Now let's add that and see what happens. Now let's run this. Now it's still giving us an error. Cannot specify both as is and any index or columns and index or columns. Okay, now let's just use in place equals to true and say in place equals to true, right? Now let's go ahead and check for results again and see. Check results. Now let's say check up dot columns. Now let's run this. Saying invalid syntax. Okay, you see what I told you about commenting now? Look, now we have successfully corrected that, right? Now let's go ahead and just run all. Okay, now we have to just go ahead and correct it. Then loan amount, right? So the next thing we have to handle is loan amount term. So loan amount term, then loan amount term. Then we also have for credit, right? We copy this and we'll paste it here. Also have for credit history. I think that's the last we have with missing values. So we go here and say credit history and credit history, right? Now, the next thing we have to do is let's go ahead and run this, right? And just delete this, double D, then delete this. Now let's go ahead and check for results. Check result. Now let's say DF, sorry, check off dots. It's not. I'm sorry, Siri, I wasn't talking to you. Dot is not dot sum. Now let's go ahead and run this. Okay. So why are we still having one missing value for loan amount? Why are we still having one missing value for loan amount? Now let's change this to be field, right? And let's run all cells. Oh, it simply means that we have successfully handled all our missing values, right? We have successfully handled all our missing values. Now, the next thing we have to do is changing appropriate data types, right? Now, to do that, let's go ahead and say checkup.info. Now, let's run this. Now, when you check this, you can see we have loan ID. But before that, let's go ahead and do something. I want us to check the df.head, so we can always mistaken it because I'm used to df. So checkup.head, of course. Let's run this so we can see what we are doing. So this loan ID object, it is correct because we have an letters before the code or whatever. Then gender, correct. Object, yes. The married object, correct. Dependent object, incorrect. This has to be an integer. Then education object, this is correct, right? Self-employed, correct. Applicant income, correct. Co-applicant income float, correct. Then loan amount float, correct. Then loan amount term float, correct. Then credit history float, correct. Property areas, okay, object, correct. Then loan status object, correct. Now, as you can see that the only thing we actually have to do is go ahead and change our dependents from object to integer, right? From object to integer. So to do that, what we have to do is Let's go ahead and say change dependence from objects to integer to integer. Okay. Now, what we have to do is to do that, we say take up dependence. I know that we are going to encounter an error here, right? But I am purposely going ahead with this to show you the error we are going to be encountering. And after showing you the error we are going to be encountering, I would also like to draw your memory back to a tutorial we worked on, all right, on Power BI. So let's say this is equals to take up, then dependence, then dot as type int. Now let's run this. Boom. Now this is the error we are encountering. This is the error we are encountering. Now, if you remember at the beginning of this tutorial, I already showed you this error. I already told you that this is a data cleaning we actually have to do. Now, I want to draw your memory back. In the last Power BI tutorial we uploaded, where we did a thorough cleaning using Power Query Editor before going into building our dashboard, right? You can remember we encountered a similar challenge to this, where we were actually trying to change our data type to the appropriate data type, but we encountered an error because of we have non-numerical characters. Now, and we also handled it using replace values. Now, this is the same challenge we are encountering here, and we are also going to be handling it using dot replace in Python. Now, let's just go ahead and create another code here, and let's say eliminating non-numerical characters and changing data type. Now, before we go there, I want us to create another code so you see what we are trying to handle. So let's say value count. So you can use this using dot value count, or you can also do this using unique. So we can simply say take up, then let's say dependence, right? Then this should be dot value underscore counts, right? Now let's run this. Now when we run this, you see that this is actually what is giving us that error, this 3 plus, right? Because Python is dictating this plus as a non-numeric character, right? Just like the same challenge we had in Power BI, right? So we have to eliminate this, right? We have to eliminate this plus sign using dot replace before we can actually go ahead to change to integer. Now to do that, we say take up dependence is equals to take up dependence, then dot rename, dot replace space, right? Then, so what are we replacing? We are replacing 3 plus with 3. So we are replacing 3 plus with 3. Then we can then go ahead and change data type. Okay, then in that, so we can simply copy this code here. Then we'll Oh no, so what did I do? I simply copy this code here and paste it. Right? Now let's go ahead and run this. Okay, let's go ahead and run this. Now, as you can see, we can go ahead and delete this now. As you can see, we have successfully changed the data type, right? But let's go ahead and confirm result. Confirm result, right? Now, the next thing we have to do is confirming results. We just do checkup.info. Now let's go ahead and run this. So when you go ahead and run this, let's look for dependents. As you can see, we have successfully changed the data type of dependent, right? Now, we have successfully handled our missing value, right? And we have also successfully changed our column names, right? Okay, and we have also seen how non-numerical characters can actually pose as a problem when we are trying to change our data type, right? Now, the next thing we have to do is handling visualizing and handling outliers. Now let's say handling outliers. Now let's go ahead and make this a markdown and let's run this. Now, but before we go ahead to handle outliers, we first have to extract our numerical and categorical columns. Now, when we are talking about outliers, outliers only affect our numerical columns, right? So we have to extract our categorical and numerical columns, and we use that using the select, all right? The type dot select dot the types. Now to do that, let's call our numerical column numerical underscore columns. So this will be equals to, sorry, I'm trying to remember the code. Num underscore columns. This should be equals to sec up dot select underscore the types. Then so select underscore the types. Then we say include should be equals to, trying to remember the code and I hope it's correct. Include should be equals to objects. I think that should be in small letter. Objects and category, right? Now let's go ahead and run this and see. Okay, so as you can see, we have an error, and okay, they say positional argument follows keyword argument. So what am I getting wrong? Okay, I think I have to put something like this here. Now let's run that again. Boom. Now we have that figured out. So let's go ahead and check results, right? To check results, we can simply call out num underscore posts. Now let's run this. Boom. As you can see, we have all our numerical columns, all our, okay. Now, if you notice something, we were supposed to extract our numerical columns, but we ended up extracting our numerical columns, right? So we just have to go ahead and change this to cat underscore codes. So it will be for our categorical column. So as you can see, we have our categorical columns all extracted from our original data frame, which is checkup, right? Now we can go ahead and extract our numerical columns. Now to do that, we say num underscore codes is equals to checkup, right? Dot select underscore the types, okay? Then you go to include equals to, so open and close, then we'll say, so what are the types of category numerical columns we have in Python? So we just say our floats and our integer and our ints. Now let's go ahead and run this. Okay, it does not add between parentheses. Now let's run this again. Boom. Now let's go ahead and check for result. Now to check for results, we just call num underscore rows, that means numerical columns. Boom. So as you can see, we have successfully extracted our numerical columns. Now we can go ahead to check for our outliers using our num underscore rows. So what we have to do is checking for outliers. Now to check for outliers, we are going to visualize this using our box plots. So in other data sets we are going to be working on in this tutorial, we are also going to be checking other methods of handling outliers too and visualizing outliers. But for this particular data set, we are going to be using our box plots. Now, to check for our outliers, the first thing we have to do, let's go back to the libraries we imported. As you can see, we only imported Python, right? Now, we can simply go ahead to import matplotlib. So we simply say import matplotlib dot matplotlib.pyplots, right? As plt. Now, let's go ahead and run this again. Then we can go back to this. Now, checking for outliers using box plots. To do that, we go ahead and say the first thing we have to do is we have imported matplotlib already. So we just go ahead and set our figure size, and doing that, we use plt.figure, right? Then we say fixed size should be, what fixed size should we use? So we can simply use, let's use 12. We can adjust it as needed, 12 by 61, right? Now we just have to close this too. Now the next thing we have to do is let's create our box plot, create box plots, right? Now to do that, we simply say num underscore cos, which is our data frame we are working with. So dot box plot, right? So rotation, now what am I doing? Dot box plot. Then let's keep our rotation as 45 as usual. So we can simply add our title, right? Now to add title, we simply say plt.title. Then what should we use? We can simply say box plots of numerical columns, box plots for outliers. So this should be a string, box plots for outliers detection, right? Now the next thing we have to do is we have to go ahead and show it. So to show our data, our visual, we just use show plt.show. So plt.show, right? Now we can simply go ahead and to ensure that our diagram doesn't go moving around, we can just tighten our layout, right? Now let's go ahead and run this. Okay, nice. Okay, title. Run this again. Okay, I think this is becoming, it's looking too big for me. So let's just say it's becoming, it's okay. We use 12 by 61, quite big. So we just change it to 6 instead. Now this is our box plot, right? This is our box plot. But I don't really like the way this box plot is looking. So there's something I want to do. I want to visualize this. I want to visualize this box plot as a subplot. So each of the numerical column, we have its own box plot, right? So this will actually help us clearly see the outliers we have for each columns, right? So we just have to create a subplot to visualize the box plot. Creating a subplot, right? To visualize outliers with box plot. So to actually create this subplot, it's going to be a long code. So I'm just going to fast forward the video. So we just simply go ahead. So this is the code. So this is the code we are going to be making result. So all we just have to go do is go ahead and run this code. So once we run this code, as you can see, that we have actually successfully created our box plot. So now, as you can see, we have actually plotted a subplot or box plot to actually show if we have outliers in our codes, right? Now, when you look at box plot for dependence, you can see that we have no outliers here, right? Now, when you look at box plot of applicant income, you see that we have outliers here. So there are outliers here. We have outliers here also. We have outliers here, and we also have outliers here, and we have outliers here, right? We have outlier and an outlier here, right? Now, the next thing we have to do is we have to go ahead and handle the outliers. Now, in Python, there are various ways we can actually handle outliers, right? But we are trying to make it that the higher we go in this data cleaning marathon, the more difficult our data cleaning process becomes. Now, for this particular section one of this marathon, we are not going to handle our outliers. What we are going to do, we are just going to cap it, right? Now, when you cap outliers, you do not eliminate them, right? You just like the name implies, you cap them to ensure that they do not actually affect your analysis. In a case where you want to actually go ahead and do your exploratory analysis, so you cap them, right? When you're capping them or visualizing them, you're not eliminating them. You're just trying to like break their wings to make sure that they do not affect your analysis in any way. Now, to do that, we need to import another package, another library. Now, let's just go up here. To import the library, let's just go up here and note that we can simply come here and actually import the library, right? Or we can just go up there to actually ensure that everything is arranged. You can simply come up here and import it. Now, the library we are going to be importing is the visualize, right? Now, to import that library, we are going to be importing that library from a Python library we call SciPy. Now, to do that, we say from SciPy, I think I already have SciPy maybe installed. So we say from SciPy.stats.mstats to import Winzurize. Now let's go ahead and run this. Okay, it's telling me cannot import Winzurize. Okay, let's know why that is happening. So SciPy dot stats dot mstats import Winzurize. Okay, so I think we made a mistake in the spelling, so it should be visualize, right? What's visualize? Now let's go ahead and run this again. So we have successfully imported that, right? Now the next thing we have to do is we actually have to go ahead and tap our outliers or visualize our outliers. Now to do that, we are going to be using a code. So this is quite a long code. So I'll just be writing it out and pasting it here, right, to make this a bit faster. Okay, so this is the code we are going to be using for this, right? So what we just did here is we just had to set the limit, right? Then we created a variable, right, a data frame to actually hold the visualized columns, right? Then this is us applying visualization to all the columns. Now let's just do, let me just put definitions to this. So let's say creating visualized boundary. Now, what you need to understand is this is flexible, right? You can actually use whichever limit you want on this. So it is flexible. So this is the upper boundary, and this is the upper boundary, and this is the lower boundary, right? Just remember when we maybe if you actually go the statistics, you can remember when we are just doing class boundary, right? When we have the lower boundary and the upper boundary, when we are dealing with is it goods data. So this is just something similar we are actually doing here. The next thing is let's just say here we created a data frame, or we visualize columns. Then this is where we apply to the data frame, apply the visualization, applying visualization, right? Now, once we go ahead and run this, once once we go ahead and run this, right? Now from here you can actually see that our outliers has been tracked, right? So we have come to the end of this particular data cleaning for this particular data set. Our number one data set, 4 more to go. So let's just go ahead and look at what we did from the beginning to the start. Now the first thing we did was importing our necessary libraries here. Then we imported our data sets, right? We called our data set setup, right? Then this is us doing investigation into our data sets where we look for the first 5 rows, right? So this is us doing data investigation where we look for the first 5 rows of our data using dot head, right? Using dot head, so we are able to see the different columns that we have and also get a sneak peek into our rows. Now we also look for the last columns, right? Last 5 columns, where we noticed here that we had an issue in with three plus, right? Now the next thing we did was get more information on our data set where we try to know how many total entries we should be expecting and also try to determine the data price of our data of our columns and also try to determine if we have missing values. Now, this is where we got statistical information on our data set. Remember, we are still in the data investigation process. Now, this is actually where we checked for our missing values, where we saw that we have several missing values in several columns. Now, this is us visualizing our missing values using MSNO missing null. This is where we started our data cleaning. This is just us checking our data sets. Now, this is us renaming our data set to ensure consistency. Now, this is where we check the results after renaming our data sets. Now, this is where we also check for our missing values. Then this is where we handled our missing values using Beefy and Elfie method. Now, this is us checking for the results of our missing values after handling them. It was successfully handled. This is where we also got another, where we also did info, getting more info on our data set. Then this is where we checked our data set to go ahead and handle our, so go ahead and change our data type into the appropriate data type. We did value count for dependents. As you can see, we have this thread plus. Then this is where we started eliminating the non-numerical column thread plus. We use it dot replace to replace thread plus with thread. Then we change the data type with to integer. Then we confirm the results, which shows here that it has been done. Then we went ahead to start handling our outliers. But before we went to handle our outliers, we extracted our numerical and our categorical columns. So this is just extracting our categorical columns, which is our strings. So we extracted our categorical columns, then we extracted our numerical columns here. Then this is us visualizing our outliers. We visualize our outliers here, but we also went ahead to visualize it as a box plot. This is what we call a box plot, where we visualize each row, where we visualize each column of the data set, right? Now, this is a box plot visualizing all our numerical columns to detect outliers. We were able to detect outliers in 5 of the columns, then we went ahead to pack our outliers. Now, we have come to the end of phase 1 of the data cleaning marathon. See you in phase 2. Now, this is the second data set you're going to be working on. It's called the Marketing Campaign Data Cleaning Project. Now, this is the data set you're going to be working with, right? It's a marketing campaign data set. Now, let's just get started. The first thing we have to do is let's go ahead and import necessary libraries. Import libraries. Now let's just go out and click M and run. Now the first library we are going to be importing, of course, is importing pandas as PD. Importing pandas as PD. Then we have to import numpy as NP. Then we also have to import matplotlib. Matplotlib pyplots as PLC. Then we also have to import Debun. Debun. Then let's import missing now. Let's import warnings. Then let's say warnings dot filter warnings. Then let's ignore that. Then let's go ahead and run this. Now the next thing we have to do is let's import our data sets. So import data set. Now let's call it df is equal to pd.read underscore csv. Then let's say arrow. So we go ahead and copy our file paths. So we copy as paths and let's go here and just paste it. Then we can run this. Now the next thing we have to do is let's check. Let's do our data investigation. Data investigation. Then we can also click and M, then run. Then let's check for first 5 rows. Now to do that, we say df.head. Now let's run this. Now when you see, if you actually followed our tutorial, the previous tutorial we uploaded in Power BI dashboard tutorial, where we did data cleaning with Power Query Editor, you will find out that I talked about delimiter issues, right? Now this is just a typical example of delimiter issues. Now when you see here, even though this is a CSV file, but when you look at this, there's something you notice here, right? As you can see that before this income, it has slash T, right? Before this kid home, we have slash T. Now this is for the rows, right? This is for the columns. Now let's look at the rows. Now also you see that what is separating each rows is this T slash T, right? Slash T slash T. So what we have to just do is we just go ahead and copy this slash T here. So this simply means that slash T is actually what is separating, is the delimiter that is separating these data sets, right? Each columns for and each rows in this data set. So what we just have to do is we go here and specify delimiter is equals to, say delimiter is equals to, then we go here and paste slash T. Now let's go ahead and run this again. And let's go ahead and run this. Then let's go ahead and rerun this. Boom. Now, as you can see, we have actually figured that out, right? Now, the next thing you have to look at here now is let's go ahead and analyze our data set. So let's just come here and say, let's just say 20 and let's run this. Okay. Now let's go ahead and analyze our data sets, right? Now, as you can see here, we actually have the ID, right? The ID, we have the year births, then we have education, we have marital status, we have income, right? Then we have kid home, then we have teen home, then we have dates, right? Dates, customer dates, this is a date. Now we have recency, right? Now we have month wise, then we have number website months, accepted TMD. Now, there's one thing I want us to do, right? Now, you know that this is a synthetic data set. Now, before we go ahead to start analyzing this data, right, I want us to copy these columns, right? Now, let's copy these columns, every column here, right? Now, let's paste, copy it, right? Now, let's go to Monica, right? And let's say I got this data set from Cargo, but I am not really understanding 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 the columns, right? Not really understanding the meaning of the columns, right? It is a marketing campaign data set. Please go to these columns and explain them and explain what they mean, right? Now we paste it here, then we go ahead and paste. Now we allow it to explain it, right? Now, as you can see, we have the year of birth to the customer, okay? Now, education level for the customer, marital status, income, kid home. Now, this means the number of children living at home. This can impact the types of products the customer is likely to purchase, okay? The number of teenagers living at home, similar to kid home. The date the customer was acquired, okay? Recency, the number of days since the customer last purchased, okay? Then month-wise, the amount spent on wine in the last year, okay? This is specific category spending metric. Number web visits or the number of web visits, then accept camp indicate whether the customer accepted the first campaign, okay? Then accepted campaign to indicate whether the customer, okay? So this will mean that they ran 5 different campaigns, okay? Indicate whether the customer has made a complaint, okay? So this is encoded where 1 means yes, 0 means no, okay? Cost contacts, the cost associated with contacting, okay? Revenue, response. Okay, so now we have clearly understood the data set and what we are working on, right? Now, when you're building a project to add to your portfolio, right, one thing you should do is you create, let's go ahead and ignore this. Now let's run this. Um, so one thing I always like doing is explaining data sets, right? Explanation explaining columns meaning, right? Now, what we have to do is we can simply go here and copy this. Simply go here and copy this. And okay, now we can copy this, then we come here and we can simply paste it, right? Then we can simply dash, dash, no, dash should come here, dash, 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 okay, dash, then dash, 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 complaint, dash, then dash, dash, then dash, dash. Then we can simply go out and click M and let's run this, right? Now this gives an explanation, right? Gives an explanation of each column, right? It gives an explanation of each columns, right? Now we can go ahead. Now the next thing we have to do is let's go ahead and check for, let's get more info on data, info on data. Now to do that, we say df.info. Now let's run this. Okay. Now, as you can see, we have a total of 2,240 entries, right? 2,240 entries, right? Then we have our ID, right? We are going to drop this ID column. Then we have our year birth, right? Which is an integer, okay? But before we go ahead, let's go ahead and do this so we understand what we are doing. So let's just go ahead and check for first 5 rows, right? Now we say df.head so we can analyze the info section properly. Now, when you look at this, right? When you look at this, you see that we have year of birth as integer, right? Year of birth as integer, right? We have to handle that. Then we also have education, education as an object, which is correct. Marital status object, which is correct. Income is float, which is correct. Kid home is integer, which is correct. Sim the same thing, which is correct. Then date customer is object, which is incorrect. We have to change it to date time. Then we have recency as integer, which is correct. Then we have month wise as integer, which is correct. Then number of visits integer. So from month one to the end should be integer. Now let's check if that's true. So this is for month wise, right, to the end are integer, which is correct. So when you look at this, it simply means that we don't really have much conversion to do when it comes to data type. We just have to work on the dates conversions, right? Now, now we are still in data investigation, so we are going to ignore that for now. Now let's check missing values. So missing value should be df.isNull dot sum. Now, when you look at this too, you see that the only missing value we have here is for income, right? The only missing value we have here is from income. The other ones, there are no missing values in the other columns, right? Now, the next thing I want us to look at is statistical info. Statistical info. Now, this is df.describe. Now, let's go ahead and go into our data cleaning, okay? Now, but before then, I want us to check for duplicated values. Duplicated values, right? Now we say df dot duplicated. Now let's run this. Duplicated. Then let's do dot sum. So we have 0 duplicated values, data cleaning. So we click out and mark down, then we run. Now let's just go ahead and call our data frame. Our data frame. Now let's say df dot head. Now let's limit it to 3. Now the first thing I would like us to do is let's go ahead and drop the ID column, right? Now drop ID column. Now to do that, we say df ID equals to df ID drop. That's correct. Now let's run this and see the index of columns. The drop. Okay. I say df is equals to df. So I think I'm getting this code wrong. Now let me go ahead with the long. I actually dropped a column. So I did it with df equals to df, then dot drop, right? Then we have to specify the column. Now let's say column should be ID. Then I think we have to do axis is equals to 1. Now let's go ahead and run this. Now let's go ahead and check results. Check results. So to do that, we say df.head. Now let's specify 3 again. Now let's go ahead and run this. Right, as you can see, we have successfully dropped the ID column. Right. So the next thing we have to do is let's go ahead and next thing we have to do is let's go ahead and handle our missing values. Right. Handling missing values. Right. Now we say to handle our missing values, we say df dot it's null. Let's know dot sum, right? So let's know the columns with missing values. So we only have income with missing value. So we handle that using mean. So we are going to fill the missing value with the mean of income. So handling income missing value with income, right? Now, firstly, we have to calculate mean income, right? So this should be equals to df. Then this should be income dot mean, right? Then handling the missing value, handling the missing value, right? So this should be df is equals to df, and we have to handle the missing. So to handle the missing value, when we say df, then we specify income, right? Then we specify income. Then this should be equals to df, right? Then income again. Then this should be, so we use dot spinner. So dot spinner is actually used to handle missing values, right? So we now make use of the mean income we calculated, right? Mean underscore income we already calculated, right? Then the next thing we have to do is, okay, I think we are having a mistake here. So let's go ahead and run this, right? Now let's go ahead and confirm results. Confirm results. Now to confirm the results, we do df dot head, right? Now let's specify 3 again and let's run this. Now let's see. Oh no. To confirm that we have handled the missing value, we do df.ignore, right? Dot sum, right? So let's run this. Now, as you can see, we have successfully handled the missing values, right? Now, what else do we have to do after handling our missing values and dropping the column? The next thing we have to do is we have to check for outliers, right? Checking, checking for outliers, checking for outliers, and handling outliers, right? Now let's turn this to a markdown and run it. Now for these outliers, to check for our outliers, we are going to be using the IQ arrow. We are going to be using IQ arrow, that means interquartile range, to check for our outliers and also eliminate our outliers. Now, before we go ahead to start checking for our outliers and handling outliers, I think there's something we are missing. We have to handle our data type, right? So we have to change our dates to date time, right? To date time. And to do that, we use PD for date type, right? Now, before we proceed, I would like us to just create another column here and let's move it up. Let's take it up and let's get the info, right? Info, and let's do df.info, right? Now let's run this. So as you can see, we have these dates here, right? These dates, year dates that is integer, right? And also year dates that is integer, and also we have date customer that is integer also. So we have to change them to our date time. So there's one thing you actually need to know, right? Now, when you look at this year bet, right, and when you look at this date customer, one thing you need to understand is that for here we are only dealing with year, right, and not full day compared to this. So here we are only dealing with years, not full dates compared to this, right? Now, there's no need for us to convert this, right, to date time formats, right? So keeping it as an integer is simpler, okay, and more efficient when it comes to data cleaning. For this, there is no need. So this is just the year the customers were born, right? So for this, there is no need to convert it to date time, right? So the only one we need to convert to date time is the date customer, okay? Now let's move ahead. I just wanted to explain that. Now, one thing I want us to do with the year bets is to filter unrealistic years. For example, when we have a year 1600, right? Now you will know that there's no way someone that was born 1600 would be alive today. So it is very unrealistic, right? So what we have to do is I want us to filter unrealistic years, right? Before we go ahead to change the date type for the dates customer. Now, to do that, let's say filtering unrealistic years, filtering unrealistic years, right? Now, to do that, we say df will be equals to df, okay? Then this will be equals to df, then this will be equals to year bets, which is the column we are working with, year underscore bets, right? Then we have to close it, of course, right? Then we say greater than or equals to any year greater than or equals to, let's use 1900. Okay, now let's close that. Then we say we use and, okay, then we open this and we say df Okay, then we open this and we say year bet. Okay, then we close this, right, and say less than. So that means any year bet that is less than 2025, right? I mean, there's no way we can have a customer that was born less than 2025, right? So, so we close this. Now let's go ahead and run this. It's giving us error year bets. Okay, that's because we are not using the correct spelling, right? So this should be year bets. So let's just go here and year bets. Then let's go here and run this, right? Now we have successfully done that, right? Now we can go ahead and change the data type, okay? So we are changing the data type for date customer, right? So we say changing data type for, now to do that we use td to date. So now to do that we can simply say df would be dates, right? Date customer. So that should be inside the string. Date customer is equals to df. No, this should be equals to pd dot to dates time, right? Then this should be equals to df. Then we say date time. Now let's go ahead and run this. So we have an error. Okay. Now let's check why we are having that error. So they're saying date time. Okay, I think this is formatting issue. Okay, so this is the way the date is formatted. So to actually do that, we just have to simply specify the format, right? So the format will be date, month, and year. So let's go ahead and run this again. So it's giving us an invalid syntax. Okay, that's because we added another comma here. So let's run this. Boom. So now that's worked. Then let's go ahead and check for results. Check results, right? Now to check results, we say df.info again. Now let's run this. Now as you can see, we have successfully changed date customer to date time, right? Now we can simply go ahead and start checking for our outliers and handling our outliers. But before we do that, let's extract our numerical columns, extracting numerical columns, right? Now let's call this num underscore cols, which is numerical columns, is equals to df dot select underscore the types, right? Include should be equals to floats and ints. Now let's run this. Okay, so we should have this here and this here. So let's go ahead and run this again. Now let's go ahead and check results. Check results. Then we simply say num underscore code, which is our new data frame, dot head. Then let's say we are looking for the first three rows or first three rows only. Okay, so as you can see, this contains only our numerical column, right? It contains only our numerical column, right? Now, the next thing we have to do is let's extracting categorical columns, extracting categorical columns, right? Now, to do that, we say cat underscore code, just similar thing that we did. So we say df dot select select underscore the types, right? So this should be include should be equals to include should be equals to um category category small letter please category and objects, right? Then we can simply cover this and run this. So let's check results. Then here we can say paths underscore code dot head. Then we specify 3. Then let's run this. So as you can see, we have just two categorical columns here. We have the graduation and the education, sorry, and the marital status. Now we can go ahead and check for outliers, right? Like I mentioned, we are going to check for our outliers using IQ arrow, which is our. So now before we go ahead to start handling our outliers, I want us to plot a histogram, right? I want us to plot a histogram for our numerical columns, right? This will actually help us dictate if we have outliers. So if any column is skewed, either skewed to the left or skewed to the right, then we can say it has outliers. Now to do that, we are going to use the code, right? Now let's go ahead and run this. So so this should be non-cos, right? Now let's go ahead and run this again. So we'll wait for it to plot. So this could actually take some time, okay? It was even faster than I thought. These are all the numerical columns we have, right? These are the numerical columns we have. Now, when you check recency, you can see that recency has a normal distribution, right? So we can simply say we have no outliers here. Then for this, you can see that we have outliers. It is skewed mostly to the left. This is also skewed to the left. This is skewed to the left. This is skewed to the left. Now, in case you're finding it difficult reading this, we have no outliers. So another thing we can actually do is to plot a box plot, right, to properly visualize our outliers. Okay. Now, to do that, what we can simply do, we can say create a box plot, okay, to visualize our outliers. Okay. Now to do that, we simply use this code. Okay. Now, now let's go ahead and run this. And we wait for the results. Okay. So as you can see, this is actually the result, right? We have here. So as you can see, we actually have outliers, right? In most of the columns, right? Most of the columns have outliers, right? Now, one thing I want us to do is I want us to calculate the number of outliers for each column using IQ arrow. Calculate the number of outliers for each column using IQ arrow. Now to do that, we are going to use the code. So this code is a bit long, so I'm just going to paste it here, right? So first we have to say this is outlier, right? Now this is simply what we just did here. It's quite understandable. We are just trying to use IQ arrow to calculate, right, the number of outliers, okay, for each column, right? The number of outliers for each column. So that's just what we are trying to do here. Now let's go ahead and run this. Now, when you see that this is the number of outliers for each column, right? Now, as you can see, we have one outlier for year. Then we have 8 outliers for income, 35 outliers, 226 outliers, 174 outliers, 223 outliers. Now you can actually use any bound of your choice, right? You can use any bound of your choice. So the choice is just to make what normally the standard bound is what we actually use here. Now, as you can see, these are the outliers that we have, right, in each column. So you can see that some columns are free of outliers, other columns we have a lot of outliers. Now we are going to be eliminating all the outliers. Now, to handle the outliers, we are going to be handling the outliers using the median, right? So we are going to be filling the outliers with the median, okay? Now, handling outliers using median. And you might be wondering, why are we handling outliers with the median, right? So one thing you need to understand is that the median is resistance to outliers, like it is resistance to outliers, unlike the mean, right? Now, when we replace our outliers with median, it will actually help us to preserve our central tendency, right, on a data without being extremely skewed. Now, to handle the outliers using median, we are going to be making use of this code, right? Firstly, we have to calculate our median, of course. Then we now replace the outliers with the median of each variable, right? So for each column, we calculated the median, and then we are replacing it with the median, right? Now, okay, I think I made a mistake here. This should be non-cos. Non-cos. Now, let's go ahead and run this. Now, this simply means that we have successfully handled the outliers, right? Now, after handling our outliers, there is one thing I want us to do. I want us to, let's plot a box plot plus plus let's plot a box plot, right? To show the distribution of our data after handling outliers, right? Now to do that, we make use of this code. Now let's go ahead and run this. So as you can see, we have actually handled our outliers, right? We have handled our outliers. Now, when you actually look at this after handling our outliers, when you look at these columns, you will find out that we still have some outliers here, right? We still have some outliers here. Now we can go ahead and use other methods, right, to handle these outliers entirely. But for this particular project, we are just going to keep it. So remember in the last project, we just visualized our outliers alone, right? So there are other methods that we can use. Once you know that we use the IQ arrow. Now, but you see that the IQ arrow did not entirely eliminate the outliers, right? So what we can go ahead and do is we can simply go ahead and cap the outliers, right? To avoid or preserve data structure while also limiting the influence of our extreme values, right? Now remember in this particular project, we actually did similar thing here. So what we just have to do is we can simply go ahead and copy this, right? And simply go ahead and copy this and just paste it here, right? So it's the same column name. So it's the same data frame name. So there's no need to actually change anything. So what we simply have to do is go ahead and run this. Okay, now it is showing that Windsorize is not defined, right? This is because we have not imported our Windsorize. Now, just like the way we did in the last project, to import our Windsorize, what we have to do is from SkyPy dot stats, right? Dot mstats, right? Import Windsorize. Now let's go ahead and run this. Now when you go ahead and run this again, When you go ahead and run this again, right, you will see that we have successfully capped our outliers. Now let's go through what we did from the beginning. Now, the first thing we did was importing our necessary libraries. Then we imported our data sets. Then we did our data investigation, right? Then we explained our columns so we can actually understand what each column mean. Then we went ahead to actually get more information on our data type, where we noticed that we have some columns that need to be changed to their appropriate data types, right? Then we checked for missing values and we found out that we have some rules meeting in income. Then we went ahead to get statistical information on our data set. Then we checked for duplicated values, which came out as none. Then we went into our data cleaning where we dropped our ID column. Then we went ahead to actually handle our missing values using the mean, right? Then the next thing we did was we went ahead to filter unrealistic yield, right? Then the next thing we did was we changed our data type for the date customer, right, to the appropriate data type, which is date time. Then the next thing we did was we went ahead to handle our outliers. But before handling our outliers, we extracted our numerical columns and also extracted our categorical columns. Now, the next thing we did was we plotted a histogram to actually visualize the distribution of our data. And from the histogram, we explained that we saw some outliers in some of the columns. But to further ex- but to further understand that, we also went ahead to plot a box plot to also show our outliers, which we discovered that we have columns with outliers. Then we also went ahead to calculate outliers for each column using our interquartile range. Then after setting our lower boundary and our upper boundary, we found out that we have several outliers in several of the columns. Then we went ahead to handle our outliers using our median, right? Now, after handling our outliers using our median, we went ahead to check for the results, right? Then we checked that some columns still has outliers in them, right? So which simply means that our IQ arrow did not totally eliminate the outliers, right? Now the next thing we actually have to do is we went ahead to cap or visualize this, okay? Visualize the outliers to avoid its effect on our analysis in case we want to go ahead and do our exploratory data analysis, which is not the case for this project. Then we have come to the end of the project. See you in project 3. So welcome to the third part of the data cleaning project. So the next project we are going to be looking at is the fake job post, all right, data cleaning project, right? Now, this is the data set we are going to be working with. Um, so this is the data sets we are going with, not this one. I think that should be 25. Yeah, this one. So this is the data set we are going to be working with, the fake job postings. Now, as usual, the first thing we have to do is let's import libraries. Import libraries. Now let's go and say markdown and let's run this. Now we have to import numpy as np, import pandas as pd, import misino as msno. Then we can import matplotlib dot pyplot as plt. Then we can import cbon as sns. Then we can say warnings, import warnings, then warnings dot filter warnings, then we'll say ignore, right? Now let's go ahead and run this. So let's wait for it to run. Okay. Now the next thing we go ahead to do is import data sets. Import data set. Now to do that, we say df is equals to pd.read underscore csv2 csv, and we say arrow. So let's go and copy parts. So we copy as parts, then we run, we paste it, then we can run this. Now let's do our data investigation. Now we go ahead and run this. Now the first thing we have to do is we do df.head. Let's check first 5 rows. So we do df.head. Okay, so let's run this. Now as you can see, this is what our column look like. This is what our columns look like. So from here we have already seen we have missing values. Then we have the job ID, we have title, location. Okay. Then we have departments. Then we have company profile. Then we have description. Then we have requirements. Then we have telecommuting benefits. There, if the company has a company logo, I think 1 is for yes, 0 is for no. Ask questions, employment type, required experience, required education, industry, function, fraudulent. Okay. Then okay, so that's it. Now the next thing I want us to do is let's go ahead and check for duplicated. So we say df dot duplicated. Okay. Df dot duplicated. Let's say dot sum. Then the next thing I want us to do is let's do info. So we say df dot info. Okay. So we have integer, objects, 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 objects. So 17,880 entries. So this is quite a large data set. So let's check for missing values. Missing value. So we say df dot is not dot sum. Let's go ahead and run this. So as you can see, we have quite a large number of missing values for each row. Okay, that's quite a large number of missing values for each row. So we can decide to drop some missing values, or we can decide to fill them with the mean, median, or with the beefy or vacuum method, or even with the mode. So, but we are not in the data cleaning phase yet. So the next thing I want us to do is statistical info. Statistical info. Then we do df dot describe. Right. Then let's run this. Now this is the data cleaning phase, right? Now the first thing we have to do, let's store the top 5 rows. So let's say df dot head, or let's just make it 20 to get a better glance of what we are working on. So this is it. Now this is what our columns look like. This is what our columns look like. Now, when you look at this particular data set, there is a lot, when I say a lot of data cleaning that we will have to do here. We have a lot of data cleaning we have to do here. from handling missing values to dropping some columns to handling text inconsistency and the rest of them. So there are a lot of columns we have to clean up here. But then before we go ahead, the first thing I would like us to do is let's drop the job ID column, right? Because that doesn't actually add up to our analysis. As time goes on to, we will decide if there are more columns that we would want to drop. So we say drop the job ID column, job ID column. Before we do that, let's add here and say check for columns. And let's say df dot columns. Now let's run this. Okay. Now these are the columns we have. Now to drop the job ID column, we say df dot drop. And we say columns should be equal to job ID, right? Then in place equals to true. Column should be equals to job ID, then in place equals to true. In place equals to true. Right, then we'll close this. Then what we have to do is copy job ID and paste here. Now let's go ahead and run this. Now the next thing we have to do is let's verify. Now to do that, we just say df.columns. Now let's run this again. So as you can see, we have successfully eliminated the job ID, right? Now the first thing I want us to do is I want us to remove duplicate rows. Now let's check for duplicate, right? Check duplicate. Let's check for duplicates. Now to check for duplicates, we'll say df dot duplicated. Now let's run this. Now let's say dot sum, right? So this we are trying to ensure that no job was actually posted twice. That means there are no duplicated rows. Now you see that we have 281 duplicates. We have 281 duplicates, right? So as you can see that we have 281 duplicates, right? So what we have to do is drop duplicate, right? We have to drop duplicates. Now to drop duplicate, all we have to do is we say df dot drop, right? Then we say underscore duplicate. Then we say this should be in place equals to true. Now the next thing we have to do is verify this. So to verify this, we do df dot duplicated, right? Dot sum. Now let's run this again. Now we have successfully handled our duplicated values. Now the next thing we have to do is let's check for missing values. Check for missing values. Now to do that, we say df dot sum. Sorry, df dot ignore dot sum. Now let's run this. Now as you can see, we have several missing values in each column, right? Now the next thing we'll have to do is I want us to drop rows in key columns. Key columns. Now, when I'm talking about key columns, we are talking about the rows, the columns that actually gives more information or more details on the job. Now, for example, is the title, the description, and the company profile. So any row where we have missing values in these key columns, we are going to drop the rows, right? Now, to do that, so let's say key columns like title, key columns like title, description, company profile. Now to do that, we say df is equal to, so we say df dot drop now. Okay, so that's what we use to drop rows. So we say subsets should be equals to, so we say the rows, the columns we are dropping missing rows in is title. So we say title, so we copy this and paste it. Then the next one should be description. We copy this and paste it. Then the next one should be company profile. So we copy this and paste it, right? Okay. So we close this and we have to close this, then close this. Now let's go ahead and run this. Okay. So we have successfully dropped the rows. So we have successfully dropped the rows, right? Now let's go ahead and we check for missing values. We check for missing values. Now to do that, we say df dot ignore dot sum. Now let's run this. Let's run this. Okay. Now, as you can see, we no longer have missing values in title, company profile, and description, right? Okay. Now, the next thing we have to do is we have to go ahead and handle missing values for the rest. Handle missing values for the rest. Now, to handle the rest of the fields, we are going to fill most of them with unknown, right? So the first thing we have to do is, let's say let's handle for department. Then we'll say df department, right? This should be equals to df department, df department. Like I mentioned, when filling in missing values with something else, we make use of pinner, right? So we make use of the method fill now. So this should be dot pinner, okay? So we are going to fill it with unknown. We're going to fill it with unknown, right? Now we are going to strip this text, okay? We are going to strip it to make it clean. Now to strip it, we use str, then dot strip, right? Then we also do dot str lower, dot lower, okay? Now I explained this in the other sections too. Now we go ahead and go to the next one. Let's say the next one we want to handle is location. So we say df location. Okay, so df location is equals to df location dot final, df location dot final. Okay, then we fill it with what? Unknown, just like the above. Unknown, fill it with unknown, right? Now we say the next thing we are going to be handling is the salary range. We're going to be handling salary salary range. Now for this salary range, we are going to be filling it with not provided. But before we go ahead to fill it with not provided, we'll make sure that we are filling only the missing values with not provided. And also we are going to be ensure that we are changing the data type appropriately, right? But before we go ahead, let's confirm what data type it is. Okay, so salary range. As you see here, the salary range is an object, right? So we are going to be filling it. We are going to be handling it, like converting it to an integer instead of an object, right? Now to do that, we say df, then this should be salary. This should be salary range, right? Salary range, okay, is equals to df salary range dot. It's null because we are filling just the missing values, right? Null. Then as type, so we convert it to int, right? Then the next thing we have to do is we then fill it with dot. Let's just copy this and paste it here. Then we'll fill it with dot filler. Okay? And we are going to be filling it with not provided. Not provided. Now the next one we are going to be handling is requirements and benefits, right? So we are going to be filling them with not provided or not specified, right? So all we just have to do is we just have to copy this, right? Then we say handling requirements and benefits. So because they were during the job posting, the job poster did not specify the requirement and the benefit. So we are just going to be leaving it as not specified. So all we just have to do is paste this, then we copy requirements. Yes, okay, requirements, right? So that's what we are working on, requirements. So we say requirements, we just paste it here, requirements, and this should be requirements. Then we just say not specified, right? Now we also copy this here and we just paste it here. Then we paste requirements with benefits. We say benefits, which is also not specified, right? So we also say benefits, okay, not specified. Now the next one we have to handle is employment type, required experience, and required education. So for this, we are going to be making use of for loop. So we say employment type, employment, let's just say handling employment type, right? Required experience, right? And required education. Now to do this, we have to say, let's say cat calls, we declare a variable and call it cat calls, and let's say it's equal to the columns we are working on, right? So which will be our employment type, employment type, employment type. Then the next one should be required experience, required experience. Then the next one would be required education. Required education, right? Now these are the columns that we are working on, right? So the next thing we have to do is, now let's write our for loop, right? Now we'll say for every, so we say for co in cat schools, right? For co in cat schools, right? Then we add our indentation, right? df co, right? Then should be equals to df co dot with strip it str dot lower, strip the lower text, and also strip the, then say str dot strip, right? Then we'll fill it with, filling it with dot spinner, right? Then we say we fill it with unknown, unknown, unknown. I just hope I got the spelling of unknown though. Okay, see, I'm already seeing finna. So the next one we have to handle is industry, handling industry and function. I think that's the next one on our list. Now we just feed them with unknown, right? So we can simply just copy this and paste this. Okay. Then we just say industry, industry. But now I would like us to strip that. Okay, don't worry, we can just write the code just after it. So we just specify industry, right? Industry. Okay. So we are going to be filling with unknown, unknown, because we, the industry was not known, right? Then we have to strip lower dot st. So I think I'm missing something here. Okay. Then we do the same for benefits. So to make it a bit faster, we can just copy this code here and paste it. Then just change it to, okay, sorry, function, not benefits, please. Function. So we change it to function. Now the next one we have to actually work on is fraudulent, right? Fraudulent. Now for this fraudulent, we are going to drop the missing rows, right? We are going to drop the missing rows because this is the target, it is the target column. That's when we are handling our missing values. But normally there should be no missing values. Let's confirm if we have missing values here. Okay, as you can see, we don't actually have any missing value. So normally, because this is the target, that means when we are building our machine learning, this is the target where we have 0 or 1, right? When you're building your classification machine learning model. Okay, so I think this is virtually all. So this is it. So let's go ahead and run this code. But before then, I feel like we have a mistake here. This should be department. I think the department is in small letter. So okay, yes, this is correct. So let's run this though and see if we have any error. Okay. Now let's go ahead and confirm missing values. Confirm. Let's just say we confirm missing values. Now let's say df dot is null dot sum. Right. Now let's run this. Okay, so we still have missing values in departments. So let's go ahead and check. So we say df dot. Okay, I think I've seen the mistake. So we added an e. So let's rerun this and let's rerun this. Boom. As you can see, we have successfully figured that out. So you see, we have successfully figured that out. So let's go up. There's something I want us to check, right? Now, when you look at this particular column, right? When you look at this particular column, these particular columns. So you will see that we have a lot of things we have to actually handle in the rows. Like when you look at this, you will see that some of the rows are having URL, right? Some of the rows are having URL. Some of the rows are having slash slash. So these are things we actually need to, handle. Well, let's take a look at it, right? So these are the things we need to handle. But I want us to do something. Let's do value count for that. Let's do validation, right? So we do df dot value underscore count. Now let's run this and see. Okay. Now I want us to actually look at the columns, the rows. I want us to look at the rows. So to understand some, okay, this is another one we have the comma, the slash, comma. So we need to strip all this. So this is another one. We need to strip all this. So this is why data validation is very important. So we see this URL here, right? This URL. So when you see this URL, the slash, slash slash. You can see. So all these things we need to actually strip them. We need to actually strip them, right? And I can see some HTML tags too. So I can see some HTML tags too that needs to be stripped, right? Some HTML tags that we need to strip also, right? So, and when you look at it, you see that we have inconsistent casing. That means lowercase and uppercase. When you look at this thoroughly, you see that it is inconsistent. So we also need to fix that, right? Now let's go ahead and do that. So we'll call this cleaning text columns, right? Now, before we go ahead and write the code, there are some libraries we have to import, right? Because as you can see, we saw some HTML columns, right? HTML tags, right? So we have to import the beautiful soup and request. So we import arrow and import beautiful soup. So this is actually libraries used for this is actually used for web scraping. So we are trying to use it to eliminate some tags and text inconsistency. So beautiful soup. I think this should be capital. I'm not sure. Let me try small letter. So let's try small letter and see. Okay, so let's try capital letter. I think it's either small or capital letter. So let's one module named beautiful soup. Okay, I think I'm getting it wrong. Okay, this should be from the export, sorry, import beautiful soup. Okay, so let's run this again. So it is still giving me that error. So what could be the problem? Now let's go back and recheck. So import requests, import from BS4, import. Okay, so this should be beautiful soup. So I think that's work. Okay, now let's go back. Now to clean the text columns, right? So this is going to be a very long code. So I'm just going to paste it, right? I'm just going to paste this. And please note that these notebooks are available on request. So this is the code we are going to be using. right, to handle this. Okay. Now, what we have to do is, let's go ahead and run this. Okay, I think it has finished running. Now let's confirm that. So let's reconfirm text cleaner. Now to do that, let's say df dot head 50. Sorry, let's make it 20, please. Okay, 50 will be too long. Okay, so as you can see, it is looking much better. Don't you think so? It is looking way better. Our text is looking cleaner now, right? It's looking cleaner. It's looking cleaner. Let's make this 50 so you see for yourself too. Okay, so this is looking cleaner to me. So this is looking cleaner. It's looking cleaner. All tests are consistent. So the next thing we have to do is let's look at the location, right? I don't really like the way the location is, right? Because as you can see here, it's giving us country, which is US, state, New York, then New York, right? So it's giving us NZ, Auckland. So I don't really feel like this is actually cool. So what we have to do now is I want us to actually split the location column to country and state, right? To city and sorry, to city and country, please. City and country. Right. Now to do this, we are going to be using this code, right? So this is us specifying that we want it to be splitted to state and city. Now, when doing this, you need to be careful, right? Now, because when you look here at the location, you will see that the country US comes before the state. Okay. Now, you must make sure that the state country, right, is coming before the city, right? Because if you say city first before country, so your data is going to be showing US as a city and then New York as the country. So you just have to be careful. Then after that, we specified, we just strip, right? We strip the columns, right? Then let's just go ahead and run this. Now let's just go ahead and confirm this. Now to reconfirm this, we say df.head. Okay, now this is going to create another column, right? It's going to create two new columns where we will have the state, country, and city. Now we'll just have to end up dropping this. Okay, so let's just run this and confirm that. Okay, now let's go down. So as you can see, we have the city and we have the country. Now it simply means that this particular column is now not useful. So we just have to drop it, right? And to do that, we say df dot drop, right? Column equals to location in place equal to true. Now let's go ahead and confirm this. Confirm if location column. Confirm if the location column was dropped. Was dropped. Now to do this, we say df.head. Now let's run this. So as you can see, the location column has been dropped, right? Now I always like doing this. Okay, drop location column. Now, the next thing I would like us to do is, I would actually like us to remove very short job descriptions, right? So you know that a job description is not supposed to be short. So we are going to be removing short job description. So removing short job description, right? Now to do that, we just say df is equal to df, then we'll say df, then we'll say description, right? Description, right? Dot script dot len. So this actually counts the number of words. So where it is not greater than 50, it eliminates it. Now let's run this. Okay, I think, okay, it's not STL, please. Okay, so we have successfully done that. I also want us to check where job title is equals to description. Okay, so we go and job title equals description. So we are handling roles where job title is the same thing as description, right? So do that we say df equals to df, then this should be description, right? Description. Then we close this, then equals to df, then title. Okay, title. So because we do not have much numerical columns, so this is when you look at this data set, it is more of a text data set than numerical data set. So because we do not have much numerical data set, all we have to do is there is no need for us to eliminate outliers. All right. So all we have to do is we simply have to just save this as a CSV, right? So we just say saving our clean data set. So to do that, we say df.to CSV. So we specify the name we want to call it. So let's say plain quick job posting dot CSV. So with this, we can simply go ahead and start creating our Power BI dashboard if that's what we want to do. So for the course of this tutorial, I'm just showing you how you can actually save your clean data sets. Well, first should be a capital interface. Now let's go ahead and run this. So this has been successfully saved. So once I go on my laptop now, I'll be able to find it. So we have come to the end of this project. See you in project 4. So welcome to the fourth project. So in this project, we are going to be working on an e-commerce company, right? So we're cleaning an e-commerce company data set. Now this is the data set we are going to be using, okay? So first, let's just copy this. So the next thing we have to do is we have to import our necessary libraries. So importing necessary libraries. Okay, so we turn this to Markdown and we run this. So we import pandas as PD, import numpy as NP, import matplotlib, pyplot as PLT, import cbon as SNS. Then let's import warnings. Import warnings. Then warnings dot filter warnings, ignore. And let's import missing null as MSNO. Now let's run this. So let's wait for it to run. Okay. So the next thing we have to do is let's import dataset. Import dataset. So we just say df is equals to pd.read underscore csv, and let's paste this there, and let's do df.head. Now let's run this. Okay, so now this is the data set we are going to be working with. So as you see, we have the row ID, other date, ship mode, customer ID. Then we have the customer name, segment, country, city, postal code, region, product ID, category, subcategory, and product name, right? Then we also have cell. Okay, now let's go into our data investigation. Data investigation. Right, let's do markdown and let's run this. So the first thing I want us to check is, let's check for info on data sets. Now we do df.info. Okay, now I want us to properly analyze these data sets. Now, when you look here, you see that it has 9,800 rows, right, and 18 columns. Okay. Now, when you look at this, you see that these are the various columns we actually have in this data set. All right. Now, when you also look at it, you will find out that we have some columns with missing value, right? We have some columns, either one column with missing values, but we are going to still reconfirm that. All right. Now, when you also look here, you see that we have different data types, okay, like row ID, integer, other ID objects, and the rest of them. Okay. So we also have other dates, which is objects, okay, which, if you have been following this tutorial, you will know that we say that we have to, this is incorrect. So we have to confirm that there are some data types that need to be changed to their appropriate data types, right? But let's go ahead. So the next thing I want us to do is let's check for duplicate values. Check for duplicate. So we say df dot duplicated. Now let's go ahead and run this. Okay, let's say dot sum. So it simply means that we have no duplicate values, right? So we have no duplicate values. Okay. Now the next thing we actually have to do is let's check for missing values. Missing values. df dot is small dot sum. Now, as you can see, we have postal code with 11 missing values. Now, let's go ahead and visualize that using missing null. Visualize missing values. So we say MSNO dot bar. So that should be df. Okay, why we wait for that? Now, this actually tells us the pattern of missingness. Okay, it tells us the pattern of missingness. So as you can see, the only one with missing value here is the postal code. Just the same way we confirmed using is small. Now we have to go into our data cleaning. So let's turn this to a markdown and run this, right? Then the next thing we have to do is, the first thing we have to do is, let's handle our missing value. Handling missing value. So the only place we have, the only column we have a missing value is in postal code, right? So what we'll do is we are going to fill it with unknown. So to do that, we say df postal code, right, is equals to df postal code. Then we say dot final. Okay. Then we'll fill it with unknown. Unknown. Right? Then let's go ahead and run this. So once we run this, we can go ahead and check. We check, right? And to recheck, we can simply do df.itsno.com. Now let's go ahead and run this. Okay, so as you can see, we have actually handled our missing values in our postal code. Okay, now the next thing I want us to do is I want us to go ahead and fix our data types. All right, but to do that, let's first of all go ahead and do df.head. Let's do df.head, right? So now let's go ahead and analyze this. Okay, let's go ahead and analyze this. So now when you look at this, you will find out that there are some columns we need to change to their appropriate data type. Like we have ship date that we need to change to date time. And we also have another date column, other dates that we also need to turn to date time. Now this poster ID is giving us an object. So we are going to be leaving it that way. Why? Remember that we had missing values in poster code, and because of those, we filled the missing values as unknown. If we want to actually change postal code to an integer, it's not. We are going to have issues with that, right? So we are just going to leave postal code as this, as we are not actually using it for any analysis. Now let's convert date date columns to date time. Now to do that, we say df other date is equal to pd to date time. Okay, then df other dates. Okay, now the next thing we have to do is we do the same thing for ship date. Now we say ship date equals to td dot to underscore date time. Then we'll say df. Then we'll say dates. Say ship dates. Ship date. Now let's go ahead and run this. Okay, we have an error there. We have this formatting error here. So the say it doesn't match this. Okay. So we just have to use this formatting here. Now what we have to do is we simply say, all right, then we do the same for this. Okay, so let's go ahead and run that. again. Now let's go ahead and confirm it. Confirm it with df dot info. Let's go ahead and run. So as you can see, we have successfully converted them to date time. So the next thing I want us to do is let's check for and handle outliers. So handling outliers, because we have a self column. Now let's go ahead and check for outliers. Outliers with a box plot. Now to do that, we say SNS dot box plot, right? Then X should be equal to DF and cells, right? Cell. Then the next thing is we go ahead and put a title. We say plt.title, title. So let's just call the self distribution with outliers. Self distribution with outliers. Okay. Now let's add should we add sticks? Okay, let's just leave it simple. Let's go ahead and say pst just show. Alright, so let's run this. Now as you can see that the cells column is having outliers. So we have outliers there. So what we need to do is we go ahead and so the next thing we have to do is let's go ahead and dictate outliers using our IQL. So let's dictate outliers using IQL. So we'll just use the same code we have been using, right? So we just set the upper and the lower boundaries, and let's go ahead and run this. Now we have a total of 1,145 outliers, right? Now the next thing we have to do is let's go ahead and handle our outlier. Okay. So to handle, let's say handling outliers. Handling outliers. Now to do that, we handle handling outliers. So let's go ahead and run this. Okay. Now we have successfully handled our outliers, right? Now I also want us to go ahead and cap it. Okay. So we have successfully handled our outliers. So let's go ahead and we visualize this. Okay. So let's call this after handling outliers. So let's go ahead and run this. Okay, so as you can see, we have successfully handled our outliers. Okay, thank you for coming to the end of the marathon.